Hi guys, welcome to session 33 of Java Full Stack Made Easy. So in this session, we will be talking about streams, which is one of the most talked about topic when it comes to Java 8 features. And in this session, we will also be performing some of the commonly used stream operations, that is filter, map, sorted, distinct, collect, count, and reduce. So we will see each one of them one by one with very simple examples. After this, we will be using a more realistic example. So first, let's understand these operations with very simple examples. After that, we can complicate the things by introducing user-defined collections. Fine. So let me just clean up everything that I have written before. Fine. So one of the stream operation we have already seen, that is the for each, right? So let's save it. And now first, let's talk about what exactly is a stream, right? So a stream, by definition, a stream in Java is a sequence of elements that supports various methods to perform operations like filtering, mapping, and reducing, right? So streams basically do not store the data. It operates on the source like collections. Fine. So do remember this point: streams do not store the data, they process the data. And the streams definitely were introduced into Java 8. So let's take a real life example to understand what exactly a stream is all about. Think of a water pipe, right? So carrying the water, right? So you have a tap, from one tap to another, like you connect a pipe. So you connect this pipe to carry the water, right? So consider this pipe as a stream, and the water that the pipe is carrying as data. Fine. And now what you can do is you can filter it, right? You can transform it, or you can collect it. You can, that means you can filter the data, you can transform the data, or you can collect the data, right? Like in that example of uh, pipe and water that I told you, you can collect the water, you can transform the water, or you can filter the water, right? So similarly here, streams can actually carry the data, and they can filter the data, transform the data, collect the data without changing the source, that is the collection. So streams do not modify the collection, but they perform the operation, right? So let's now understand how can we make use of the streams. Fine. So the very first operation that I'll be performing with the stream is the filters. I want to filter the data, right? So that's what I want to perform. And for filters, what they do, these filters returns a stream that includes only those elements that are matching the given conditions. You can consider this condition as predicate. Okay, so let's see how can we make use of a filter. So let me create a list here, and I'm going to create a list of integer, and I'll call this list as numbers. And then in the previous examples and all, while creating a collection, we used to create it like list, then the integer list number is equal to new array list or new vector and all. And then when we are creating a new array list, at that time what we used to do, numbers dot add, numbers dot add, numbers dot add, right? There is again a shortcut way of doing that. What we can do is we can simply say arrays dot as list. So this particular function can be used to add the elements directly without using the add method multiple times. So we can simply say 10, 20, 11, 13, 14, 18, and 22, and 19. So some random numbers I'm taking into this particular list. Now what is my requirement is that I want to filter out all the odd numbers. I want to only have the even numbers. After filtering, I just want to have the even numbers, right? So that's my requirement. So how will I do it? By using streams. Fine. So you can simply say the numbers, sorry, numbers. Let's call it as numbers instead of number. So numbers dot stream. So if you see that this particular function stream performs the stream operation, which was again added into Java 8. So now what stream operation I want to perform? I want to perform a filter on this, and it requires a predicate to be provided. That means the condition to be provided here. So what is my condition? My condition is each one of these element should be divided with 2 and the remainder should remain 0. If the remainder remains 0, then that element should be added. That element should be taken. A rest all element should not be. So that is my condition, right? So let's now see how can we do this. So here we can either provide a method reference or we can provide a lambda expression, the condition. So let's provide in a lambda expression here like x, and then simply x modulo 2 equal to 0. So that should be there. So this is what I am actually looking for, filter, and that's it. Now I also want to print this particular stream. Fine. So whatever elements are filtered out, that is something which I want to filter here and print it out, sorry. So if we want to print it, what we used to do, we can make use of a for each, right? So that performs a uh, printing for each element that's available into this particular stream. So here itself we can chain it. We can put a dot and go for a for each here. Once again in the for each we have already discussed, we can again go for a lambda or we can go for a method reference. So in this case, I'll go for a method reference just to show you that we can combine the lambda as well as the method referencing together. So I can go for just a print ln. Done. So let's save it and run this piece of code and get only the even numbers listed out. So here we go. All the even numbers are listed out: 10, 20, 14, 18, 22. All the odd numbers are removed from here. Fine. So that way we can make use of filters, right? So what they do, filters, they include only those elements that are matching the given condition. So if it matches the given condition is what the element should be divided with 0 and the divided with 2 and the remainder should remain 0. That means it should be a number divisible by 2. And all those elements that are divisible by 2 remains in our stream, rest all are filtered out. So that's what a filter does. Let me copy this and put it into the repository, and this is our day 33, right? Session 33 means date 33. So let's say day 33. Let's create a new repository. Let's call it as demo 1 and let's call this as filter stream. Okay, this is a simplest of stream filter example that I can show you. Just getting out the even numbers. Now, obviously in future, I'll be showing you a more complicated operation, including the filter itself. But as for now, just to understand what exactly the filter does, the syntax and what elements are filtered out, let's put this first into the repository, understand the other operations. After that, we can apply it on a list maybe of type player, right? A list of player can be applied and we will filter out all those players that belong to maybe RCB team. Things like that can be done. Or you can also have the employees who belong to HR department, or maybe the customers who have the unpaid bills. So those type of filtering can also be done using streams. So in the example that I shared, I am sharing you a very basic example. Obviously in future we will be making it more complicated. Now let's talk about another concept of another frequently used feature of a stream, that is the map. Now what map does, like we discussed before, we can filter the data, we can transform the data. So maps, they are used to transform the data. Map, what they do, they transform each element in a stream into another form, right? So let's take an example and understand what exactly I mean by transforming the data. Let's take a string type of collection, and let's just give some names here like Virat, Rohit, and let's say Sachin. So three elements I'm taking here. And now what I want to do is I don't want to perform a filter on this. I want to perform a map on this. So let's provide a map. And now what I would like to do with this particular elements that are available into this particular list. let's call this list as what? Names, and change this to names. And what I want is I want to just convert these names into uppercase. Fine. So that's what I want to do with this particular data that I have. I want to transform it into an uppercase, right? So let's see how do we do it again. So what we can do is we can simply use a to uppercase method. So we can say x dot to uppercase. That's it. So we will be able to convert each one of these element into uppercase, and we are also printing that. So we should get a result printed into capital case. Here we go. It's converted into, all the names are converted into capital cases. Similarly, what we can do is we can perform any transform. What we can do is, let's say some people have given us the email IDs, and they have included capital cases, small cases, everything. So what we can do is we can convert all the emails given by the customer, convert them into smaller case, and then save it into our database. So things like that can be done with the maps. Fine. So we have already used for each for this. So what it does, performs printing. In this case I'm using a for each for printing. You can use it for other purpose also. So for each I'm using it for printing. So what it does is performs an action for each element in the stream. Fine. So similarly what we can also do is, let me just first put this into the repository, and let's call this as demo2 map. Demo2 map. We can perform sorting as well by using stream. So let's see how do we do it. So I'll go back to my old list, which is number dot stream. Now I don't want to filter it. What I want to perform now is I want to perform sorting on this. So how do we perform sorting on this? We can simply say sorted. So this particular function is already available for us. We can perform sorting. You can also see when I see sorted, it comes up with a comparator as well. So if you are using a sorted with a comparator, at that time you provide your own comparator in there, right? Collections dot reverse order. If you do, in that case, it is going to sort it in a reverse order. Fine. So now let's see, once I perform a sorted one, whether I'm gonna get the this particular data sorted or not. Let's save it and run this piece of code and see whether it is sorted or not. So you can see 10 and 22. So obviously it is sorted. So since I have already told you that sorted can take either a comparator also, so you test it by providing collections dot reverse order and check whether the elements gets sorted into reverse order or not. So let's just call it as demo3 sorted. Let's put this data. Done. Now similarly what I can also do is, like we have used a sorted function, we can also use something called as distinct, which removes the duplicate from the streams. So let's just go back here and first let's add duplicate elements into the stream. So let's have 10 twice and also 18 twice, maybe 18, 22, and once again 18. I will write it here. Fine. So now I just want to perform a distinct operation. That means it should get me all the distinct data from the available data into the collection. So let's save and run this. So now you can see 10 is repeated and 18 is repeated, which is not included into my list. Fine. So that's how the concept of distinct works. So this obviously is used to remove the duplicate entries. So let me copy this and let's put a demo4 and call it as distinct. All right. So now what we can also do is like in the first example which I shared with you, where you have a pipe and then the water is being transferred through the pipe, right? We can collect the water, we can filter the water, we can transform it and all we discussed, right? So we can also make use of a collect. So a collector, that means when we have a stream, we can collect a stream into a list, into a set or a map or other structures. So let's see an example of the same and understand what is it all about. Okay. So once again, uh, let's have a stream again of type names. Let me just go back to the concept of names that I was using there. Filter and then map, right? So for a map, I used a string, right? Let's go back. Anyways, let's create a list of type string names is equal to uh, arrays dot as list. Let's go back and put up the same names that we have added in our example. Or else what I will do is I'll take it from here itself, the map example. So this is something which we printed here, right? But since stream doesn't have their own data, but after performing some operation, what we want is we want to collect that particular data. So in this case, what I did was I converted everything into uppercase, right? All the names were converted into uppercase. Now what I want is I want these names to be stored somewhere. Fine. I want these names to be stored maybe in a set or maybe in a list. So let's see how do we do that. So this was just about printing it, right? So I don't want to print it. I want to get these particular names somewhere. So this is my stream. So instead of performing a for each and performing a filter, so let's perform a map so that it converts the data into uppercase. And after that, what we can do is we can simply say collect this. Collect. Now, while collecting it, we can collect it as a list, we can collect it as a set, or we can collect it as a map and all. So let's first perform a collect it as a list. So we can simply say collectors. So there's a collector interface and there's a collectors class. So we are going to make use of a collectors class available. Collectors dot to list. Fine. So this actually returns a list with us to us. We can say it returns a list of type string, and this is what upper names is equal to, right? So we can retrieve it as a list, or we can take a set. So if we take a set, we have to store it into a set, right? So let's take it as a list itself as for now. So I'm taking it as a list. So we have retrieved a list. Now I want to just print out all of that. So we can simply say system.out.println and print that upper names, or we can make use of a lambda expression for each and then print everything. So let's just run it. So we got the uppercase details. Now this uppercase details are actually stored into a new list. So what collector is doing, what this collect is doing is it is collecting that data, because streams, they don't have their they don't store the data. Because they don't store the data, if we want that data at that time, we can simply collect the data by using a collect function, and then we can collect it as what, by using collectors we can collect it as a list or maybe a set or maybe a map as well. Fine. So this is how we can make use of collect. So let me put this again into the repository. Let's call that as collect demo 5. All right, so let's just go back. So what were we discussing? Filter we discussed, map we discussed, sorted we have discussed, that distinct and collect. So two more thing, count and reduce. So let's go ahead and we'll finish off those two operations as well. Now as the name suggests, count counts the number of elements with the given condition, right? So let's perform a count. So here is my list. So what we will do is we'll take we'll go back and take the number list which I was taking in the filters. So let's take this list. So here is the list I have. And what I want to do is I want to here in this case I was filtering out all the even numbers, right? So all the even numbers were taken. Now I want to count how many even numbers are there instead of just printing every single even number there. So let's see how do we do it. So we don't want to perform for each for this. So I just want to perform a count on this. So count this. After counting all of this, I want to actually store it somewhere, right? So if you see the return value of this count, it returns me a long data, right? So I have to store it into a long variable. So let's say long uh, counter or count of even is equal to fine. Now just say system.out.println and count of even, save it, run it. So that should count to me all the even numbers. So let's cross verify it whether we have 5 or not. 10, 20, 14, 18, 4 and 22, 5. So 5 even numbers we have. So it can also be something like if you want a realistic example of a count, what we can do is we can filter out. In this case we are filtering out all the even numbers. What we can do is we can filter all those let's say all those employees who are managers, and then we can count how many managers are there in our organizations. We can also do things like what we can count how many products are out of stock. We can count how many products are in offer which we are giving for discounted price. So all such things can be done. So in these examples I'm using very simple examples, but obviously I'll use more complicated examples later. But initially I want you to understand the operations first. After that we can apply it in real time. All right, so the last operation is reduce. Okay, so first thing is what reduce does. Reduce combines elements into single result, and this is used when you want to perform aggregations like sum, min, max, etc. So let's understand what exactly do I mean by performing a applying the aggregation on it. So here we already have a list, and then we in this case we were counting it, right? So let's perform a reduce on this. Okay, instead of filtering and printing it all. So I want to perform a stream, and then I want to do a reduce. So you can see that it takes an integer identity, then binary operators. Fine. So that's what I want. So once again, uh, now what I want is I want to sum up all these elements that are there with me. So if I want to sum it up, let's take some few elements so that we can easily get to know what is the sum of this. Let's say 2, 5 and 3. So that should sum up 10, right? And the two arguments identity I have to provide here. So I'll say 0, and then I have to provide a predicate here as well, right? So in this case I'll use a lambda expression again. Fine. Let's say x and y, and I'll say x plus y. That's it. So I'm counting everything. Yeah, looks good. And once we do this, this returns me the sum of it, right? So let's store the sum. Acha, already I have a long, so let's call it as sum. Take a sum. Let's save it, and there we go. So here we have the sum of this 5, 3 and 2. We can also get the average of it, or we can get the maximum out of it based on just the condition that we provide here. So let me just put this into the repository first. So this is my demo 7 probably, and let's call this as what? Reduce. Okay, so let's commit this. All right, so I hope that you have understood now the common impressions about the streams, right? Now what we are going to do is in the same reduce stuff, like I told you, uh, we can get some min, max and all those stuff. So what we can do is let's try and simply change the condition there, which is in terms of what? Reduce and get the maximum out of it, right? So in this case, two arguments are passed. Let's say uh, if this particular, if x is greater than y, then store x or else store y. Let's save it and let's test whether we get the maximum number from there or not. 5 we are getting, that's good. So let's say this. Yeah, there we go. So this way we can get the maximum minimum. This is the ternary operator for which I did not show you any example in my previous videos and all, because this is just a very basic operator that can be used into Java or any programming language. So that way we can get the maximum or minimum and all that. So we can, you can just reduce it. You can go with the lesser than symbol and get the minimum value out of this. So I'll put this as well into the repository just for your understanding. Demo 8. All right, so some common operations about the streams we have discussed into this particular session. In the next session, again, we will be talking about more operations with the stream, and obviously one more realistic example with the streams we will use, and we will also, we can even perform chaining in the concepts that we are using. We can make use of a filter, and then with the filter itself we can make use of the count, and then we can make use of the for each, and we can use a map, to list, everything can be chained together. Uh, Multiple filters can be changed together. So all that is all possible with the stream. So in our next example, what we can do is we will see more operations about the streams, and also we will use the more realistic example related to streams, so that we can use these operations that we have already learned. Some more common operations are like finding the first element that is available into a stream, finding any elements, or maybe matching, any match, all match, none match. So these type of functionalities can be used with the streams. So see you in the next video.